Hey guys, today we're going to do a probability theory worksheet 1. Just a reminder, if you need to pause the video at any time or rewind, it's all in your hands. You can do whatever you need to get the notes that you need. So if you have any questions, message me, whatever you need, just let me know. All right, let's get to work. Anytime you're dealing with a probability, you're looking for a chance that something could happen. Now, when you're finding a probability, you always should get between 0 and 1 as your probability. The reason being is because you are looking at the chance of something happening. And when you think about chances or probabilities, it's like, oh, okay, there's a 50% chance it's gonna rain. There's a 70% chance it's gonna rain. Now, we are always in the math world dealing with decimal form of the percent, and every percent is actually in decimal form between 0 and 1. A 1%, or excuse me, 100% chance would be the equivalent to a decimal form of 1. And that's why every time we calculate probability, we should get between 0 and 1. If you get anything higher than 1 or anything negative, less than 0, then that means you probably did something wrong and you want to look back at your calculations. All right, so number 1, what is the probability of choosing a king from a standard deck of playing cards? Anytime you're finding something like this, you always want the total number of options on the bottom, the total number of like what is possible on the bottom, and on the top you're going to put the number of the things that you want. Okay, that's the equation or the fraction that you're going to use. So when I look at the standard deck of playing cards that's in the lesson, there's a picture showing all the playing cards. I notice that there are 52 cards total. So the total number of possibilities, there's 52. When I look at that, I also see that there are 4 kings possible. There's a king of hearts, a king of diamonds, a king of spades, and a king of clubs. So that tells me there are 4 things that I could potentially choose, so 4 things that I want out of a total 52. So I'm going to plug that into my calculator and I'm going to find the probability. So 4 divided by 52. So that gives me 0.0769. Notice that's between 0 and 1, so good, I did something right. This tells me that my probability would be, if I put this in decimal form, move the decimal, or excuse me, percent form. If I put it in percent form, move it twice to the right, the decimal, and I would get 7.69%. That means the probability of choosing a king in a standard deck of cards is 0.0769, or you could say 7.69%. All right, now let's move on to the next question. I'm just going to do a couple examples to help you get moving on this assignment. What is the possibility of choosing a green marble from a jar containing 5 red, 6 green, and 4 blue marbles? So same thing as before, the number of what you want divided by the total number of possibilities. So first we have to add all these up to get the total number of possibilities. 5 plus 6 plus 4 is going to give me 15. So the total number of marbles is 15. Now it's the probability of choosing a green marble. So how many green marbles are there? Well, there's 6. So 6 divided by 15 is going to give me the probability of choosing a green marble, which is 0.4. Between 0 and 1, I did something right. So the probability is 0.4, or you could say 40%. If I were to move the decimal twice to the right, that would give me 40%. All right, so same thing as you proceed down, you're gonna do the same type of idea for each of these. Now, the next one that I'm gonna do is I'm gonna do number 9 because that one confuses people a little bit, okay? So what is the probability of choosing the letter I from the word probability? So what I'm gonna do for this is I'm going to write out the word probability. And I'm going to do the exact same thing I did above. Number of what you want divided by the total number of possibilities. So I say, well, how many letters are there in the word probability? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. There are 11 letters. And the question says, what's the probability of choosing the letter I? Well, let's see how many I's there are. 1, 2. So 2 out of 11 is going to be my probability. 2 divided by 11, that gives me 0.18. So you could say 0.18 or 18% is the chance or probability that you'll choose the letter I from the word probability. What is the sample space for choosing a letter from the word probability? Sample space just means what are the possibilities that you could potentially choose? Well, you could choose a P, you could choose an R, you could choose an O, you can choose a B, an A, a B, I already got that, an I, an L, an I already got that, a T, and a Y. So that's the sample space. There are 1, 2, 3, 4, 5, 6, 7, 8, 9 different letters in the sample space that you could potentially choose or sample. Hopefully that helps. If you guys have any questions, go ahead and let me know. Oh, I guess there's a backside. I should continue. I'm so sorry. So let's go ahead and do a couple examples on this backside. I'll just do number 1 and number 2. So a student had to be chosen from Anne's class. There were 11 boys and 11 girls in total in her class. The teacher wrote their names on separate pieces of paper and then took out one of the papers without looking. What is the probability of selecting a boy? So same thing that we did before. These questions are just a little more wordy, right? The number of what we want divided by the number of possibilities. You know, that's kind of the important thing for this whole assignment. So the total number is there's 11 boys and 11 girls. So that means there's 22 names, right? There's a total of 22 names. Out of those 22 names, I want to find the probability of selecting a boy. Well, there's 11 boys. So what you want out of the total number. So 11 divided by 22 is going to give me 0.5, 0.5. So the probability of selecting a boy is 0.5, or you could say 50%. All right, so number 2, Thomas had a bag with 30 marbles, 12 blue, 7 red, 5 white, and the rest were gray. So there's 30 marbles. So, I mean, how many gray would there be? Let's just do this right now. If there's 30 marbles, 30 minus the 12 that are blue, minus the 7 that are red, minus the 5 that are white. That tells me there's 6 gray marbles. So I can go ahead and just, well, first erase my little mistake. And then I can just say, well, there's 6 gray. We just calculated that. I mean, we're probably gonna have to use it, so whatever. Okay, cool, now we have all of our information. Okay, 12 blue, 7 red, 5 white, and 6 gray. He took a marble, meaning he chose one of the marbles. What is the probability that it is blue? Same thing as we did before. There's 30. How many blue out of the 30? There's 12. So 12 divided by 30. 12 divided by 30 is going to give me 0.4. So the probability is 0.4 or 40%. Part B, if he puts the marble back, this is called replacement. When you put something back, it means that you choose it and then you put it back in so none of the probabilities are changed. So he puts the marble back and takes another one. What is the probability of taking a red one? So he puts it back, which means there's a total of 30. Okay, now he wants to know what's the probability of taking a red one. Well, how many reds are there? 7. So 7 out of 30. 7 divided by 30. Sorry if my calculator is a little bit dark. That's going to be 0.23 or 23%. Okay? Thomas took a gray marble and didn't put it back. What is the probability of taking another gray marble immediately after that? So this is where it's not being replaced. So he didn't put it back. This is not replacement, which means that now they want to know what's the probability of taking another gray marble. So on the second pull, what's the probability of getting a gray marble? Well, he already took a gray one out of the mix, which means instead of 30 marbles, there's now only 29. And instead of 6 gray, he's already taken one out, so there's only 5. So the probability of getting that second gray marble is going to be 5 out of 29. So 5 divided by 29 equals 0.17, or you could say 17%. Sorry, I kind of messed that up. 17%. So for the rest of this assignment, you're kind of going to be doing that same idea. Once again, if you have any questions, go ahead and message me, let me know. Hope you guys are having a great day and staying safe.